Using data to make decisions about student services with Larry Long from Michigan State University. My name is Mary Lee Demeter, and I'll serve as your moderator today. Using data to make decisions about student services with Larry Long from Michigan State University. My name is Mary Lee Demeter, and I'll serve as your moderator today. On behalf of the SAL Professional Development Committee, I would like to thank you for joining us today and participating in our conversation. I'd also like to thank members of the Professional Development Committee, Larry Long, as well as Shelley Pleasance and Margot Saltonstall from Northern Arizona University for their help in putting today's presentation together. So a few logistics before we get started. You can feel free to adjust your chat window using your mouse to adjust the size of the chat window for how you see fit. I also encourage you to participate today by asking questions or making any comments using the chat window. Or you could also feel free to raise your hand, and I can unmute your microphone, and you can ask your questions or make your comments directly and speak them to us. We'd love to hear your voice. A couple other things, you can insert some emoticons using the little smiley icon just above the chat window. If you stepped away from the session, you can indicate that you have done so by clicking the second icon in with the little man and the timer. And again, to raise your hand during the session, you can use the third icon in with the little hand symbol on it. And finally, any polls that we'll be conducting today, you can participate in them by using the little checkbox to indicate your answer, either yes or no, or multiple choice A through C, D, or E. Again, while we are primarily using the chat room, please don't be shy and feel free to raise your hand. I'll unmute your mic so you can speak to us today. So without further ado, let's get started on today's structured conversation. Student records, swipe card data, club membership rosters, colleges and universities track and store a lot of data on students. However, these data sources are often disassociated and private. Come learn about how one institution decided to merge multiple data sources together to gain insights on student experience on their campus. This structured conversation will give examples of how administrators at colleges and universities might apply data mining and data visualization techniques to make decisions about student services. So from participating in today's structured conversation, we hope that you'll learn how to identify institutional data sources that might assist in supporting students, describe how data mining and data visualization processes can be applied to student affairs, and refer to resources to develop or strengthen knowledge and skills pertaining to data mining. So without further ado, I'd like to introduce our presenter today. Larry Long from Michigan State University has 9 years of experience in student affairs assessment and institutional studies and currently works at Michigan State as a management analyst. He is primarily tasked with promoting a culture of assessment at Michigan State by coordinating assessment activities among student support services within academic affairs, student affairs, and business affairs as part of the institution's re-accreditation efforts with the Higher Learning Commission. In addition, Larry produces various reports and visualizations to assist administrators in making data-informed decisions. Larry earned graduate degrees in Student Affairs Administration, Educational Psychology, and Sociology from Ball State University, and undergraduate degrees in Modern Languages and Physical Sciences from Kansas State University. Larry's research interests pertain to fraternity and sorority life, residence life, academic integrity, and student development. And when Larry's not crunching numbers, he can be found weightlifting at the gym or traveling. So now sit back, relax, and join the conversation as Larry tells us all about he uses data to make decisions about student services. Welcome, Larry.
Thank you. Good morning to everyone, at least everyone that's still not in the East Coast where it's already past noon. Thank you all for joining the conversation. So the purpose of today's session is to give a 10,000-foot view of last month's presentation around big data to mainly highlight how you might use data mining principles to understand your student population, but also ways to visualize your data to make decisions. So I'm going to give you an institutional context. We're going to go over different data sources that you might use at your institution, and then the bulk of this is going to be giving you examples of how we use different processes. So in terms of outcomes of this presentation, ideally you'll know what institutional data sources you might have access to, describe different processes that you can use, and then also I'll refer you to resources where you can learn more about data mining, because obviously you're not going to learn it all in 1 hour. So in terms of institutional context, Michigan State University has 38,000 undergraduates, about half women, half men. We have a large population of first-generation students and a large population of Pell-eligible students. And so our main efforts have been trying to identify ways to find all the students who are falling through the cracks. And having access to all the student records, card swipe data definitely allows you to see how you might identify some of those students through different data mining processes. So when it comes to data mining, at least the main challenge that you face is how do you get the data and what do you do with it? So when I was hired in my position two years ago, they said, here we have all this data, and my first thought was, what do I do with all of this? So the data sources that I have access to are from business affairs, so transactional data, all the student records in academic affairs, health records, and so it's a lot of information. And then, sometimes people ask me, when they ask me to run regressions, is it statistically significant? And I just kind of cringe and look at them because, with all my data sets, everything is. So just because it's significant doesn't mean it's important. And so that's where some of the data mining processes are helpful. So I'm going to cover those two areas, mainly how do you get data, where can you get it from, and then what can you do with it. So sources of data. Where might you all in your institutions get data? And that's an open question. So we have student info systems, surveys sent to students, admissions, institutional records, PeopleSoft, which is similar to Banner, surveys. Not sure what PHR is. Card swipe data. Departmental operations, career services. So those are all good sources. This is where we primarily get our data from. So student records, we're a MapWorks institution. So MapWorks is a survey that goes to first-year students about the third week or fourth week of the semester and asks them about their academic behaviors. Allows us to determine if someone's expectations of succeeding in college aligns with their behaviors. We get progress reports from faculty members, and then we have card swipe data to track students' engagement on campus. And then I would say we also have two buckets of data. Some of it is real time, so we can look at it instantaneously, and some of it we get at the end of the semester. And that's more for logistical reasons. So fitness classes, tutoring, academic advising, all of that is real-time data, and it's based on card swipes. But then anything pertaining to the health clinics and writing centers. The writing center is at the end of the semester because it's an appointment schedule, so we're just downloading all the data from the calendaring system. And the health clinic data is just not something that we need instantaneously, but we do look at trends in the sense of how do students, what types of students are seen at the health clinics, and what diagnoses do we have the most on our campuses. So in addition to the ones that people describe and the ones that we use, what I want to mention is that you also can use web scraping and social media as an additional source of data. So what web scraping involves is going online and trying to mine text from different websites. So here's an example of our dining menu at one of our dining halls. And so you can go to this link down here and it would open up the menu for today. And if you want to do any type of analytics, it would take a lot of time to go through every single page for all of our dining halls for every single day and download all of that text, at least manually. So what web scraping allows you to do is to write a script that will do all that work for you. And so here's an example of I use R. When it comes to data mining, the two languages that most people use are the R or Python. You can choose whichever you want. So this is an example of using R script. So I'm using the XML package in R and the RBEST package in R, and saying here's the URL, go to that URL, and then download the text. And so when I run it through the script, what I get is this at the end where it just says, you know, for breakfast today we had scrambled eggs, hard-boiled eggs, omelets made to order. And so I just get all this raw text. And of course I just did it for one day or just for one meal session. What you could do is write a script that downloads it. This is actually what I did. I downloaded all the menus for every day for the entire year and matched it with our dining data to see how does the meal offerings impact students' attendance in the dining hall. So if we had chicken and fish, our counts were higher. If we had specialty dinners, our counts were higher. You could look at associations in the sense of what types of students tend to go to the same cafeterias. There are definitely ways that you can at least merge all the different data sources together. How web scraping is also used. Let's say that you wanted to, and this is not really higher ed, but more of a side project. Let's say you want to look at movie ratings and merge it with another data set. Instead of having to go to IMDb and look up all the movie ratings manually, you can write a script that will go to the website and actually scrape all the ratings for you and import it into a text document. So that's the whole idea behind web scraping is you essentially are creating a robot that does all the work for you. And then, so the other option is social media mining. So the search term I would use if you're interested in Twitter analytics is just going to Google and saying Twitter mining or Twitter analytics in R. And so with the Twitter package in R, you can search tweets. This little link down here will tell you how to get started, because you'll have to create a Twitter API and use that to get authorized. And so this is just an example. I can search tweets and say, you know, last 500 tweets that had the hashtag #SAChats as an example. And then what you can do with that is you can create word clouds. So this is a word cloud of just looking at the last 100 tweets of the hashtag #EatStates. And so you can see just talking about the MSU food trucks. Not really anything important, but just an example. Where text mining becomes more useful is, I mean, you can do word clouds and those are fun, but there's only so much you can do with it. Where text mining becomes more useful is when you use it for sentiment analysis, which is detecting whether or not text is positive or negative. So let's say you sent a survey to students and you had an open-ended response option where students could say, you know, let's say answer a question about their experience at your institution. It would take a lot of time to actually read all of the text, but you know, by all of your respondents, you might write a script that goes through and says, is this text that someone wrote positive or negative? So that's sentiment analysis. We could also do is classification, where you're essentially applying a tag to a word. So this text talks about homesickness, or this text talks about the dining hall. This one talks about living on campus. So that would be the classification, and then clustering would be grouping texts that are similar. So if you were looking at tweets, you might want to group things together, tweets about the same topic. So that's how text mining can at least be used to mine a lot of text data where it might not be feasible to actually read every single thing. Where this becomes more useful from a student affairs perspective would be when you're asking students for input and you want to flag concerning comments. So in our case at MSU, when we use MapWorks, we ask students to tell us about their experience at MSU, and then occasionally we've had students say they either are contemplating suicide on the survey, or they said they're contemplating homicide. And so we can actually write a script that flags that and says, here's a concerning comment, you might want to look at it. And so that's just one way of using technology to mine text without having to read everything yourself. So I'm going to switch into visualizing data. So one way of visualizing data, at least a lot of data, would be using Sankey diagrams. And I'm going to pull up this example right here. And once that loads.
Hit the follow me, and I think that it should load.
It's checked. It's not loading on my side either.
Okay, gotcha. It doesn't show up as checked on my side, that's why.
Okay.
I published the URL to the chat window, and I was able to have it load pretty easily using that, but that won't bring everybody on a web tour, but I thought I'd comment that it worked that way.
Yeah, so if you click on the link, what you'll see, I'll just describe what it looks like. So if you click on the link, a Sankey diagram is a flow diagram, and why I created that was people were asking me, in which majors do students start and which majors do they end? So as you can see, this is at least looking at the 2007 cohorts, and then 10 years later, so whether or not what colleges they graduated from. So you can see a lot of students will start in natural science and then not actually graduate from MSU, similar to other departments. After I did this, so that's just an example of everyone. When we look at it by our students of color, what we found was few students start off in the College of Music, College of Nursing, and few students graduate from those colleges. So it shows where some of our retention issues are and where some of our recruitment issues are in the sense of getting underrepresented students. So it's just an example of how using data visualizations helps us understand where we're losing our students. How we've also used this is we use the flow diagrams with residential retention, so definitely relevant for people in residence life. So an example is looking at which residence hall do students start based on ethnicity, and then do they stay on campus, do they move to a different residence hall, do they move off campus? And that definitely changed by ethnicity. So students of color tended to go to other residence halls where there are other, I would say, critical mass of students of color. Our Caucasian students tend to move off campus, and our international students tend to move off campus. So it can help understand that flow, at least throughout the cycle of students coming to campus. And then this is an example of a dashboard I created in Excel. So you can create this in Excel 2013 or newer. It's just using pivot tables and pivot charts and slicers. So if you click on the link below, that's an example of it. Let me see if this one will actually work, maybe. Okay, apparently it doesn't like those links, but they're all in there. You can look at them. What the slicers allow you to do is you can filter out the data and update the charts based on the content. So how we use this at MSU is it allows student affairs professionals to understand who goes to tutoring, who goes to academic advising based on characteristics, and just looking at overall trends. So the example that I gave you, at least that I gave you, is for the rec sports specifically. So you can look and see, you know, which type of students went to fitness classes, which type of students go to the gym. As you would imagine, more women go to fitness classes, more men go to the gym. And so one of the programmatic challenges, at least for our rec sports department here, was they actually found it was more Caucasian women that went to fitness classes, so they used it to understand, okay, why are we not getting students of color? Why are the classes not as appealing to them? And so they infused different sessions that were more appealing to that population. And then this right here is another example of creating a dashboard, but instead of using Excel, you can do it in R. What I will say is if you do it in Excel and you put it on OneDrive, the data is accessible. That's why for some more sensitive stuff, I use R because you can't download the data, but you can still use all the different charting options. You have a bit more flexibility in R in the sense of you can add different algorithms for, you know, computing things, filtering, charting. So it's really just depends on whether or not you want to code, if you just want to, you know, create charts in Excel. But there's a really good tutorial at the Shiny R Studio website. And so then what this is a visualization of our campus and our different neighborhoods. So we have 5 neighborhoods at MSU. And why I created this chart was there was always a perception that each neighborhood was more diverse than other neighborhoods. And it wasn't necessarily true, as you can see here, that it's actually River Trail in the middle that has a lower percentage of Caucasian students. And so what this is actually just a website, so it's not actually dynamic, but you could create a dynamic version of this. So you click on it and it updates the percentages and the transparency of the different residence hall buildings based on the population of interest. So it's just one way of understanding, okay, where do you have a greater concentration of certain populations? How student affairs professionals here use this is more for programs. So understanding, you know, if you have fewer students of color in, for example, North neighborhoods, you might need more support programs to help them feel a sense of belonging versus, you know, different things. How one might also do this is by major. So if you had a certain, more people of a certain major in a residence hall, you might have different programs for that group. So then when it comes to data mining, the 4 common approaches for data mining are clustering, associations, classification and regression, and anomaly detection. What clustering involves is finding data that is similar. So that could be trying to identify students with common characteristics. So if you want to know which students are more likely to use resources on campus, you can use a clustering algorithm to find that out. Associations looks at patterns. Classification or regression is what most people understand with predictive analytics, so it's simply classifying. Is someone more likely to be retained? Is someone more likely to be on academic probation? And anomaly detection is a specific way of finding things that don't happen very often. So the more common thing that everyone would know would be credit card fraud. It's not something that happens often, but you want to be able to detect it. Same with email spam. In a higher ed sense, you could apply it to students who are more likely to drop out. It's not something that happens often, at least when you look at the number of students, but it allows you to tweak it and reduce some of the false positives. So then potential analyses of how you might use the different data. At least here, the way we view some of our dining data, so we have 1 year's worth of dining data is about 600 MB of data, several billion lines of transactions. And so how we've used it is to identify changes in dining patterns. The idea being that all of our first-year students are required to live on campus and they're required to have a meal plan. If you're living on campus and you're not eating, or at least if your dining pattern changed, why not use that as a way to identify students who could use some follow-up? So we've mined our data to see, okay, has Jimmy stopped eating? Is it worth reaching out? And so it's just one way of identifying students who might fall through the cracks. As a former hall director, I would say most of my students who had mental health breakdowns didn't eat on campus, mainly because of the social anxiety of going to the dining hall. So it was definitely a good indicator of students who might be in distress. Now, of course, just because you identify a student doesn't mean they are in distress, but it doesn't hurt to reach out and say, hey, can we have a conversation? How are things going? Another analysis that we did, and I'll show you that one in a second, is looking at course combinations associated with students succeeding or struggling. Analysis that we could do but haven't done yet is computer. We actually have access to, when students use the computer labs on campus, we can actually see what programs they opened and used. So the idea being that if students are using certain programs, why not offer workshops at those computer labs on those softwares? So if everyone's using SPSS, why not offer SPSS workshops? Of course, some people are probably freaking out and thinking you could use that in other ways, but that's kind of the challenge with all types of data mining, is that there's always an ethical implication. What are some thoughts from the group in the sense of how data mining might be used to help students? So I have assessing Title IX training. So Joe's made a good comment about automating processes. So the more you can automate it, the faster it'll go. That's probably the biggest limitation of a lot of these processes is if you can't automate it and somehow get an IT person involved, that's like you're manually processing everything and coding it. It's going to take up most of the time. So if you can automate it, you can definitely implement your solutions a lot quicker. So suggestions of mining data to see common characteristics, which students use, which students with certain backgrounds are more likely to use services. So here's an example of predictive analytics, and this is a screenshot of the workflow using KNIME, which is spelled K-N-I-M-E. And so I'm an office of one with no budget, so I tend to use open source software. So this one's free. I'm just going to say it's using two processes. So I'm using a logistic regression and decision tree approach to look at which students are more likely to persist based on their characteristics. So you can definitely create a predictive analytics per model within KNIME. You could also use SPSS Modeler if you have, a commercial product or SaaS, whichever you might have. This is the RLC curve, so you can see that the logistic regression is a bit more accurate than the decision tree. Both are about 75%. It's not great, but you also don't want to overfit your model. That's just an example of using that program. This is an example of pattern mining. So I mentioned looking at course combinations. So this is the workflow for that. Two common approaches are the FP growth algorithm, which is in KNIME, or the a priori algorithm. And so what it does is it looks for common associations in your data. And so this is what it looks like when you run it. So you get something like this, where I inserted their demographic backgrounds and which courses they were in. And so then I could see if you're a male and black and you were enrolled in Integrated Studies 210 and Math 1825, which for us is developmental math, about 53% of the students ended up on academic probation. And so how this helped us is to understand that certain populations and certain courses were more likely to be on academic probation. One that's not listed here as an example is Chinese students who were enrolled in Intro to Computer Science and Psychology tended to be on academic probation. So how this helps us is it allows academic advisors to have conversation with students about their academic preparedness. So if someone says in an academic advising session that they struggle with math and they don't really plan on studying too much, and in high school they didn't study too much, an advisor might say, in order to succeed in the course combinations that they either have to study more, seek tutoring, or consider changing their schedule. It allows the student then to have a real conversation about what it takes to succeed in those courses. But as most academic advisors know, just because you told a student that you might have to study more doesn't mean that they're going to, and also doesn't mean just because you told a student not to take a certain combination that they might still do it. Sometimes, for example, we have students who will enroll in developmental math, chemistry, and biology, which is like, okay, if you can't do algebra, you can't do chemistry or biology. We know that, but a student might not realize that. And so with these course combinations, we've also set up alerts to where if someone enrolls in it, the advisor gets a flag, gets a notice, and is able to reach out. Doesn't mean that we'll unenroll the students from those courses, but at least it allows the advisor to be more proactive and have a conversation with the student. And so again, this is using the FP growth algorithm within 9. And then this is just a visualization of the same data. So it's looking at doing a network analysis to see which courses, at least which combinations of courses tended to be associated with students ending up on academic probation. So in terms of implications for practice, when it comes to merging multiple data sets and data mining, the main thing I would recommend is first establishing a task force if you don't already have one. So a committee that can look at, okay, what data sources are available, what data sources can you merge together, what policies do you have to alter in order to get access to them. Fortunately, when I started my position, when they hired me, they purposely put me in academic affairs and business affairs. That's where all the data is. And so since I work in the provost office and in the VP of business affairs office, people can't necessarily say no to me in the sense of when I ask for data. Fortunately, I haven't had to ever drop anyone's name, but at least it gives me that access to say I'm doing it for the greater good and trying to get connected to different data sources in order to understand what our student experience is. But I would say for the most part, people have been very open about sharing data and have actually asked me how I can use their data. So for example, the reason I have access to the health clinic data is they contacted me and asked, how can we create a dashboard? How can we do analytics with our health data? Obviously, there are more restrictions around the health clinic data, but we just worked around those to stay HIPAA compliant, but at the same time still understand which populations are we overserving, which populations are we underserving. And in terms of implications for policy, the main thing is understanding, again, what are the ethical use of data, who should have access to the data. So while I'm always willing to share data and I want people to use it for programmatic purposes, sometimes when people ask me for data, I have to think, okay, do you need the actual identifiable data, or can I just send you what the results are, or can I send you some other version of the data so that I'm not always sending out the raw data. So it just depends on what it is. But then also understanding, do your students know what's being tracked on them, and are they a part of the process? And then implications for assessment. My main advice is having assessment a part of your data mining processes. So when you create these different models, you want a way to understand, okay, does your model actually work? And do you need to tweak it? But then what you also could do is different analyses that'll help you understand how your trends are changing over time. And in terms of future projects here, as I mentioned, we have that predictive analytics model where we looked at whether or not students are more likely to come back. So I ran that model this year, and while I can already identify which students are less likely to return, and there might be some ways that we can try to ensure that they do come back, I'm a little hesitant when it comes to predicting who's going to come back. I'm a little hesitant to use it. So at least for the first year, my intent is just to wait and see what happens, and then see what was the actual return rate based on the model. So that's what that project is. And then what we're doing right now is working on that early alert system that I mentioned based on the transactional data. So we're actually merging in additional data sources, and in addition to the dining data, looking at library use, looking at door access, so merging all the different sources with the idea of being if you're not using your ID somehow on this campus, you're probably not on campus. So it's worth reaching out and seeing how things are going. In terms of resources and how to learn about data mining and different processes, for the actual programs, you can use, like I mentioned, SPSS, SAS, or Stata for your regressions and different data mining processes. I recommend using R or Python, at least if you're looking at some open source software. For data mining in terms of actual programs, you can use Weka or Nine. They're both open source. There are plenty of tutorials online on how to use them. In terms of learning about different data mining processes, I highly recommend Coursera.org. So there are several online courses, or at least workshops that teach you about data mining. Joe, who's actually on this session, and I both did the data mining process through Johns Hopkins, which was pretty good. So I'd recommend that. Okay, so what questions do people have? Which projects? The question is, what was my timeline for the project? Okay, so the question is, do I have a server? How do I merge all the data together? So when I first started, I actually was manually merging everything together using SQL and Access. So my data sources have the card swipe data, which is stored, like I said, in Business Affairs. Then I can use an ODBC connection to merge in the Student Information System data, and then any other sources of data that I might have. So it's all used within Access. Not the best approach, and especially for the amount of data that I had. So right now, what we're actually working on is creating bridges between the different data sources and then creating a BI system using Cognos. So that's at least the direction that we're going in. But right now, it's I guess the warehousing is mostly manual and Access, and a lot of the analytics is manual as well. The question is, how long until we were able to get results? Because it was multiple projects and multiple outcomes, I would say, depends on what it was. So with the data, if you have the data, you can get your results, immediately if you can run it. I would say your biggest hurdle is simply going to be the time that it takes to set up the analyses and get results that at least seem useful. So yeah, I would say it really just depends on how much time you can dedicate to it. So in my case, some of the visualization, because I was doing it on the spot, those don't take very long. So those Excel dashboards take me about an hour to complete, so it's not hard. Some of the more the course combination stuff, now that I've written the syntax, I can just run it And so that goes really quickly too. How long did it take me to set it up? I would say maybe 5 days. And that's the benefit of using SQL too, at least for merging the data, is once you've written all the queries, running it, in future iterations is pretty quick. But yes, you have to put in the time to set up everything on the front end. But as I showed you earlier, also with the workflows, when I was using 9, that's the nice thing about the workflow, and I'll actually go back to that slide. So let me point my clicker. So right here, what this is saying is read the data and then perform this operation. I can just change what data I import and then run the operation. So everything's already set up. All I have to do is change the data that I'm importing. And so that's the nice thing about using a workflow process is everything in the sense of cleaning the data is set up in the program. So this, all these different commands in the middle, we're actually cleaning the data, and it's actually not running the analysis until the very end. So the question is, what type of client education have we done in student affairs? So part of my responsibilities is coordinating the assessment efforts for 3 different divisions. And so what I do is I have assessment training sessions on how the different units can do their own assessments. And when I say assessment, I mean like student affairs assessment, not data mining. So it's, your traditional assessment cycle. So I have workshops on that. I have workshops on how to, or at least tutorials on how to use Excel for data analysis, how to use SPSS. So different sessions that allow people to learn how to do assessments. But then we also have a data summit every year where people can present on their assessment efforts. And it's actually next week here at MSU, but also that's where I'll talk about some of the major analyses that I've done and allow people to understand what the student experience is.
Taking a look, I think we hit all the questions. If there's anything that you're still unclear on, please feel free to ask. We still have 10 minutes, so Larry, I think we could get through the questions in the chat room, right?
Yeah, I think so. Someone asked about the name of the open source software. The two that I use are 9 or Weka. In terms of data visualizations, we have Tableau here at MSU as well. The problem with a lot of the different programs is where does the data go? And so with Tableau, you have to upload the data to their server, which has been a limitation here, which is why I don't use it. But it's definitely a useful tool for visualizing it, and you can download the free version and give it a try. Yeah, if there aren't any other questions, I would say feel free to shoot me an email if you ever have any questions. Trying to think. If you want any sample codes for anything, yeah, just let me know. I didn't want to post everything on here because the code gets pretty long.
Okay, if there are no further questions, we'll hang around in here for the next 8 minutes or so in case anyone has any last-minute thoughts and you'd like to ask us any questions. In the meantime, I'd like to let you know our next structured conversation will be on June 5th with Dr. Daniel Newhart and Dr. Larry Roper. They will be discussing publishing student affairs assessment and research, particularly in regards to the journal of the newly released Journal of Student Affairs Inquiry and Research that just came out in the fall. In the meantime, I want to thank Larry Long for presenting today for us. This has been amazing. I really love the data visualizations and a lot of, especially the open source software that you've been sharing, especially in the world of tight budgets and student affairs. Anything that's free is for me. So a couple of links I was actually trying to find towards the end here. So Larry, you and I can work together to make sure that we have those links to get them out to all of our participants.
Yeah, thank you for having me.
All right, just looking to see, I don't see any outstanding questions, but like I said, we'll hang out for a few more minutes in case anyone does have a question. And again, many thanks to Larry. Thank you so much. And for all of you who are participated in our conversation today. And I will get out the link to the recording along with the PowerPoint and links to some of the websites we discussed today, as well as an assessment of today's structured conversation. So we'd really appreciate your feedback. Thanks again, and we'll see you all on June 5th. Oh, Larry, I see that Daniel Newhart would like your email. If you could go ahead and put up the slide with your contact information on it.
Yes.